Homework 3.2 is mostly dealing with the chain rule, although it does it some different ways. In this first section, we are going to determine the derivative of each function and then evaluate at the given point. So let's look at how this looks in a couple of these, maybe just one. In the first one, we have this big f of x, which is little f of g of x, and then wants us to find f prime of 2. So the first thing is to find the derivative of the function. That's part A. And we should notice here we have a chain rule. We have a function inside of another function. This is f of g of x. And this is just directly what the chain rule is. The chain rule says you take the derivative of the outside function with the inside function still inside of it, and then multiply by the derivative of the inside function. So let's see how we use this to find f prime of 2. Well, we're going to be doing f prime of, instead of wherever there's an x, we're putting in a 2. So f prime of g of 2 times g prime of 2. And before we can do f prime, we need to see what we're doing f prime of. We're doing f prime of g of 2. G of 2, we can get from the table, g of 2 is 3. So this is f prime of 3 times g prime of 2, we can get directly from the table. G prime of 2 is 8. We still need to do f prime of 3. So f prime of 3 is 7. 7 times 8 is 56. So that is f prime of 2. Okay, let's see. I think I'll do one of these graph ones because they're a little bit different. Let's find u prime of 1. First, we need to find u prime of x. So u prime of x. This is, again, that direct definition of the chain rule. We've got the derivative of a function that's inside of another function. We do the derivative of the outside function, which is f prime, of the inside function, times the derivative of the inside function. And so now we can do u prime of 1. So it's going to be f prime of, well, now we need to do g of 1. So we can do g of 1, and it doesn't tell us any values here, but we've got this graph. G of 1 just means what is the y value when x is 1. So we're going to find g of 1. G of 1 is 3. And so we've got f prime of 3 times, now once g prime of 1. Again, it doesn't tell me the values of g prime, but I've got this graph. And g prime means, let's make sure we understand what a derivative is. The derivative is the instantaneous rate of change, the slope of the tangent line, and because g is a linear function right here, at x equals 1, the derivative is just the slope of this line. And so we can find that by finding the rise over the run. So it goes down by 3 and over by 1, down by 3 and over by 1. The slope is negative 3. Now we can also find f prime of 3. So f prime of 3 means when x is 3, what is the slope of f? F is a linear function, so we can just calculate the slope like we would in Algebra 1. We don't want to use this point, we want to use two easy points and calculate the slope by doing the rise over the run. This function goes down by 1 and over by 1, 2, 3, 4. So it's negative 1/4 is f prime of 3. So negative 1/4 times negative 3 is positive. Negative times a negative is a positive. Positive 3/4. Okay. I think you guys should be good on these. We've been doing these a lot in the other homeworks, on last night's homework. I guess I'll do one in case you, for some reason, missed it. Let's do b. dy dx, the derivative, is equal to, now this is sine to the 9th of x. The inside function, the thing that's happening here, sine of x, is being taken to the 9th power. It's not written like that, but that's what this means, is sine of x is getting taken to the 9th power. So sine of x is the inside function. This is basically x to the 9th power. So something to the 9th power, the derivative is going to be 9 times that something to the 8th power. It's power rule. We multiply by the power and lower the power by 1. And then we need to do times the derivative of the inside function, which is cosine of x. Okay. All right, I'm excited to do number 4 with you. Some of you seem to not feel comfortable with physics, and that's okay. We'll go through it over the course of the year. We'll do lots of physics examples. So here we've got the position of an object in harmonic motion on the end of a spring is this. So this is the position. There's some like object that's bouncing up and down on a spring, sorry. And y is measured in feet, t is in seconds. It says using correct units. So make sure you use correct units here. Determine the position when t equals pi over 8. Well, it already told me the position was this. So the position at pi over 8 is I just plug in pi over 8. So y evaluated at pi over 8 is equal to 1/3 cosine of 12 times pi over 8 is 12 pi over 8, which simplifies to 3 pi over 2. Minus 1/4 sine of, again, 12 times pi over 8 is 12 pi over 8, which is 3 pi over 2. You do need to know your unit circle. Cosine of 3 pi over 2, 3 pi over 2 is down here. Cosine of that is 0, so this will go to 0. And sine of 3 pi over 2 is negative 1. So we get 0 minus 1/4 times negative 1, which is positive 1/4. And this is the position. The position is measured in feet, so this is 1/4 feet. So basically the thing on the end of the spring is 1/4 of a foot away from the center of the spring. Okay. The velocity when t equals pi over 8, it didn't give us the velocity. But one thing you should know is that velocity is the derivative of position. So you take the position, take the derivative of it, and velocity is the derivative of position. Acceleration is the derivative of velocity. So that's really all you need to know from physics, is that acceleration is the derivative of velocity, velocity is the derivative of position. Okay, so we need the velocity. Well, here we're going to be finding the chain rule. We're going to be using the chain rule. So the velocity when t equals pi over 8, first we need to find a position, or a formula for the velocity. So y prime is going to be, here we've got a constant multiplier, so it's going to stay there. This is cosine of something, so the derivative of cosine of something is negative sine of that thing times the derivative of the inside, which is 12. Okay. Then we've got this separate thing. It's a plus or a minus, so we can just do it separately. So it's going to be minus. We've got a constant multiplier, so that just stays out front, times the derivative of sine of something is cosine of that thing, and we have to do the chain rule again because it's cosine of something, so times the derivative of the inside function, which is times 12, and this can simplify. So this is, we can multiply the 12 times this, multiply by the negative, and get negative 4 sine of 12t minus 3 cosine of 12t, and we're going to plug in pi over 8. So y prime evaluated at pi over 8 is equal to, again, 12 times pi over 8 is 3 pi over 2, so it's negative 4 sine 3 pi over 2 minus minus 3 cosine of 3 pi over 2. And just like before, I know sine of 3 pi over 2 is negative 1, and cosine of 3 pi over 2 is 0, so the answer is 4. Now it asks us to use units. Velocity is how fast something is moving, so it's being measured in feet. That's how far it moved, divided by how long it took to move, which is in seconds. So it's 4 feet per second. Okay, the last one. At what times are the particle at rest? So on this interval from 0 to 5. So the particle is at rest, means the particle is not moving. That's not about where it is. It's about how fast it's moving. Particle is at rest means that the velocity has to equal 0. That doesn't mean the velocity at time equals 0. That means the velocity is 0. And so I need to take my velocity function, which is right here, put it into a calculator, and I'm going to graph it on the interval from 0 to 0.5 and see where it's equal to 0. Once you put in your velocity function, I like to also put in what we want it to be equal to. I like to go to the window and put in the window it says. It says we only want to go from 0 to 0.5, so we want the times to go from 0 to 0.5. And I also changed my y's to make sure that there are at least some negatives and some positives because I want to see where it is 0. So I'm going to have to see from the negatives to the positives. And when I graph it, I get this. There are 2 different times when the velocity is 0, and I can do it 2 ways. I can press the 0 button, and I need to make sure I'm on this blue function. And when you use the 0 function, you have to use the cursor, and it asks for a left bound. That means you go to the left of the 0 you're looking for and press enter. And then it asks for a right bound. You go to the right of the 0 you're looking for and press enter. And press enter one more time, and it tells you the 0 is at 0.208. Or if you've put in the 2 things you want to be equal to each other, you can also use the intersect button by pressing second calc, just like you would do for 0, and instead picking intersect and pressing enter, 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 and it'll tell you the 0. Now I'm going to let you find this other 0 on your own, but the time is going to be 0.208, and it asks for units, so this is going to be measured in seconds. Okay, number 5 is a different question. I'm not sure how good your geometry is. This word, the normal line to the curve. Remember that normal lines, this is a tangent line, and a normal line is perpendicular to the tangent line at the point of tangency. And so to find the slope of the normal line, we find the slope of the tangent line, and the way you find the perpendicular slope is you do the negative reciprocal. So first we're going to find the tangent line slope, which is, we know the word for that. When you're finding the slope of the tangent line, that is the derivative. So the tangent line slope is just the derivative. Here we have to do the chain rule. This is something to the 1/2 power. So it's going to be 1/2 times that something to the negative 1/2 power. And a negative power means it'll be in the denominator. The 1/2 part means it's the square root. So this is that part of the chain rule. Times, we need to do times the derivative of the inside. So this is the derivative of the square root of something is 1/2 square root of that, times this is the chain rule, times the derivative of the inside function, 15x squared minus 2. That needs to be in parentheses. At the point when x equals 1, so h prime of 1 is equal to 1/2 times the square root of 5 minus 2 plus 1 is 4. And here we've got 15 minus 2 is 13. So this is equal to 13/4. This is the slope of the tangent line, but it asked for the slope of the normal line. Normal lines are perpendicular, so the normal slope is going to be -4/13. Okay, I think that covers this stuff well. There's more practice later on.